Okay. So we'll continue the relative motion as we discussed in the last lecture. So I think we have started solving some question, right? Let me just check. So I gave all the formula, right? How to write the kinematics of relative motion, isn't it? Yeah. So in a relative motion, generally what we try to calculate. In a relative motion, we try to calculate the first is called, because we talk about the two particles, so we talk about calculation of time to have some action. Okay. So let's say if two cars are chasing each other, then after what time it will chase the other car. That's one question. In case of collision of a projectile, we talk about when they will collide. Then we have question of minimum separation question, that after what time the two particles will be at a closest separation. So these are the variety of questions that will come across, and these questions can be either in one dimension or two dimension. So both kind of situations are possible, and we are supposed to write the equation. Generally, as a beginner, I will tell you how to solve as a beginner. As a beginner, you stick to the kinematical equation again, and write the kinematical equation for relative motion the way I have explained in the last lecture. Substitute the value and then get the answer. Now, if you are getting answer in that way, it means you have assured that okay, you can solve the question. Now, after that, we have many, you can say, more advanced method. You can say it's like a vector notation, vector method, or by some common sense in which you can solve the question really easy. Okay. But those insights take some time to develop. So meanwhile, you're developing those insights, I would say that okay, solve by the conventional equation method. Okay, you just take the equation at hand and then write the equation and you get the answer. So I'll demonstrate some question and we'll show you that how to solve questions of that nature. So there's a very famous question called meeting problem. What is the meaning of meeting problem? That two objects will meet each other. Okay. So it could be one dimension, it could be two dimension, it could be any it could be any way. So I'll start with something really simple, one dimension, which we have solved already. We'll do it again. So a very simple question, that there are two particles, particle one, particle two. Okay. And both are moving. So let's say the one is moving in this direction with velocity, let's say v1, and this is moving with a constant velocity v2. So we are not assuming any acceleration, simply v1, v2. And at the instant when you see this situation, the separation between them is, let's call d. A very simple question is, after what time they will meet? Very simple. What is the question? Time after which they will meet. Find time after which they will meet. So that's a pretty simple question, right? Now I will just demonstrate how to write the equation. This is pretty easy, we can do it mentally, but the thing is how to write the equation. So what is given to us is a displacement, the separation between them. So as a common practitioner of the solving problem, we choose some coordinate system so that we can write things with a position easy. So we can say let's say take 2 as origin, and the moment you take 2 as origin, you can write the coordinate of 2 also, which is 0, 0. And you can write the origin, coordinate of 1 also, and the coordinate of 1 will be how much? What will be the coordinate of 1? How far is the 1 with respect to origin? Tell me.
D comma 0.
D comma. So now you know the coordinate. Okay. Now they will meet somewhere here because both will move and they'll meet together somewhere here. Now, whenever they meet, what will be their coordinate? We don't know. So we can assume something called x comma 0. Yes or no?
Yes, sir.
And what else we can say that both coordinates, okay, both coordinates are same. So particle 1 and 2, if they are meeting, it means they will have same coordinate. Yes or no?
Yes, sir.
That's simple logic. Both are meeting, it means they must have the same coordinate. That's a simple logic. Okay. So therefore, if they have the same coordinate, so that is the condition given to you that meeting problems will have the final coordinate of the meeting particles must have same coordinate. That's the logic actually, which we apply. So final coordinate of both the particles at the time of meeting must be same. So that's a simple logic. We can write it down here. Final coordinate of meeting particles must be same. So simple. And once we know that this is the answer, you can write the answer as ax minus x naught equals to u xt plus half axt square. And now we have to express this into relative. So we have to write x relative minus x not relative, ux relative, and 0. Why 0? Because they don't have acceleration individually also. So there is no question of a relative acceleration. I hope this is clear why I'm writing like this.
Yes, sir.
And relative means what? Either 1 minus 2 or 2 minus 1. You can choose the way you want. So you can continue writing 1 minus 2 or you can continue writing 2 minus 1. So x relative means final relative position. Now we can see clearly that final position is same for both. Yes or no? Do you see that? The final position is
Yes,
same.
sir.
Yes, sir.
This term must be 0. Hinted. Now we are left with the only one term, x relative equals to ux relative into t. Now we could have started from here itself, but anyway, I wanted to show you how it comes. Is this clear?
Sir, isn't that x not related then?
Yeah. It's not relative. This is actually x not relative. Yeah. So now x not means what? Initial position. Relatively. So we have to add minus. And it means either you can add x not 1 minus x not 2. And if you write 1 minus 2, you have to continue the same process everywhere. So you have to write u x1 minus ux2. Because we're writing 1 minus 2, continue. I'm trying to solve very mechanically, like something I'm not applying brain. I'm just putting the values as the question is saying, and I'm going to get the answer for sure. So I can see the first particle will have coordinate 0, and second will have coordinate d. The first will have v2. Sorry, the first particle is what? My bad. Let me just change it. Yeah. So the first particle is how much? Coordinate is d. Second is how much? 0. What is the initial velocity of the first particle? And second? So we got the answer. T equals to d minus d upon 1 minus 2, which we can rewrite as d upon. So basically, for meeting, it is necessary that v2 must be more than v1, then only it is going to meet. Otherwise, it won't meet. Yes or no? No, this is very simple, like because it's a just a single line equation that because their separation is known to us, it's d. We know the relative velocity, which is v2 minus v1. The time after which they will meet is d upon v2 minus v1. But this way of writing will have benefit in very challenging kind of question. when things are really complex and you are not able to see things really clearly. So then in that case, this way of solving will be easy for you. For a very easy question, you can do it mentally. That with respect to one. Now the other way of thinking is, using the vector idea. Okay. So this is a pure canonical way of solving. So the method 2 is like when you think in vector form. Okay. So what you do is, for two particle motion, what we do is, we make one of them as observer. Now tell me which one you want to make observer. So choose one of them as observer.
So 2.
Yeah. So the moment you make 2 as observer, 2 will be at rest. Right? Because the velocity of 2 with respect to the 2 itself will be 0. So 2 will not be in motion, 2 will be at rest. But what is the velocity of 2? Velocity of 1 with respect to 2. Velocity of 1 with respect to 2 will be v1 minus v2. Isn't it?
Yes, sir.
And because they have same direction, so if you want to write in IJK form, you can write as v1 I cap minus v2 j cap. It's like simple. But we know that v2 is bigger, right? What I have written, it's I only. And what we know that v2 is bigger than v1. So we should write minus, which means the value is v2 minus v1 and direction is negative, minus I cap. So 2 will see that 1 is coming towards itself at what speed? So 1 is approaching 2 with what speed? v2 minus v1. And how much distance it has to travel? D only. So time will be distance upon speed, that's it. Because 2 is at rest. If you ask 2 when 1 will meet you, it will tell you, okay, it will meet me after d upon v2 minus v1. I hope this is simple.
Yes, sir.
Yes.
Any doubt in this? It's very logical. Okay. So now what happens if we introduce some acceleration? Okay. So we'll build up the idea slowly without getting. So let's say we have again two particles. So we have U2, we have U1. And let's say the initial separation is D. But U1 is more than U2. So will they ever meet? Will they ever meet? No. Is
No,
it
sir.
possible for them to meet? The answer is no. But what I do is, let's say they are driving a car and they can accelerate as well. So let's say this is A1, this is A2. And I'm saying A2 is now more than A1. So the one who can accelerate faster will eventually have more velocity than the other. Okay.
Yes, sir.
So now 2 can chase 1 eventually.
Yes.
So now instead of taking vector way of writing 1 and 2, the canonical way is best, right? Because we have only one relation, x not relative equals to ux relative into t, if you remember, plus half a x relative into t square. Now this term will not cancel. Why? because A relative here is not 0. But at the time of meeting, X relative will be 0, isn't it?
Yes.
So at the time of meeting, since they will have the same X coordinate, so can we say they will have a relatively 0 value of separation? Because they have same X coordinate, so there is no X relative, isn't it? So at the time of meeting, we know that X relative is always 0. That is the meaning of meeting. Meeting is you are at the same coordinate. Okay, X coordinate here. So can we substitute the value? Minus. So let's add 2 minus 1. That's easy. So if you choose as origin, this is D comma 0 origin. And you're not supposed to worry about the entire relative motion concept. You can do it mechanically also here. So what you can add here? 1 minus 2 or 2 minus 1. Let's write this time 2 minus 1. So 2 minus 1 means 0 minus D. What is 2 minus 1? U2 minus 1. And then A2 minus A1. Just continue the 2 minus 1 everywhere. And now you are left with a quadratic. So you can say 2 minus 1 into T. And then solving this quadratic will give you the answer. If you want to solve, you can solve, you can leave. That's all. Now, the most interesting problem that you will come across is when the accession is same. The moment you see that they have same accession, things are very easy. Because the moment accession is same, the A relative term becomes 0. So you have a simple equation to substitute and solve. Okay.
Sir, I have a doubt.
Yeah.
So in the previous page, why did you write that minus outside the bracket?
What
Minus
a
two.
minus? This is minus, no? Minus sign. X
No,
minus
sir,
X.
on the right side, minus of 0 minus D.
Where? On the previous page. This page.
Acha, no, acha, fine. No, I think I understood.
Okay, I'm writing in the different order, maybe. 1 minus 2 or 2 minus 1. You can add 2 minus 1
Fine.
or 1 minus 2. Now, the benefit of solving this way is, let's say if I give you a slightly difficult question. So this is called the meeting of projectiles. I'll show you many methods. Just this is the beginning, like how you start learning projectile motion, relative motion actually. So imagine we have two towers of height h1, height h2. And as a beginner, I have found this as a very convenient way of solving question, because it will take away all the burden of thinking, you know, the idea of vector and all. And no matter how difficult the question is, you can solve with ease. So the question is meeting of two projectiles. Meeting of two projectiles. Now, if they are meeting, no matter where they meet, if they are meeting, it means I can say they must have same coordinate at the time of meeting. Yes or no?
Yes.
Yes, sir.
Now the problem is here we have height also, D also. We have like a meeting is, this motion is not one dimension. So we have to choose a proper coordinate system so that we can assign proper X, Y coordinate for each particle. Okay. So if you think of only X, okay, because we know that we can always write the relation X equals to X naught, X minus X naught equals to UT plus half a T square. So to begin with, you have to choose some coordinate system which you are free to choose the way you want. So I'm going to choose this as origin. Not required, you can choose origin here, also you can choose origin here. Like you should choose something convenient, nothing else. So the left I'm taking as origin, this as x-axis, and the vertical as y-axis. Before you start solving, make sure that you are able to write the coordinates of each and every point. Okay. So what will be the coordinate of this point? The coordinate only.
0, h1.
0, h1. Very good. Similarly, what is the coordinate of this point?
D, h2.
E, h2. Excellent. And now, because the velocity can also be resolved, so you have to write the x component and y component. So you can write as u1 cos theta 1, and this will u1, and this you can write as u2 cos theta 2, u2 sin theta 2. And the moment you write the coordinates, your job is pretty easy. So the next part of your job is to simply write the equation in x and y separately without worrying much, or you can write the vector form directly at one go. So I'll show you how to write in different way. So let's write this equation first. So once you understand that okay, this is for x direction. So I'm omitting the x subscript because it is understood that I'm going to write for x direction. Okay. So mentally you can solve this. I mean, these are not required equation. You just write it down in mind and then substitute the value while putting on paper. So to begin with, can we write this as 0? Yes or no? The x relative will be 0 at the time of meeting, isn't it?
Yes.
So first part is done, that it is 0 at the time of meeting. The next part is very carefully. The next part is what? It is 0. Either you will write 1 minus 2 or 2 minus 1. You can choose whatever you want. So in which sequence you want to write the difference? 1 minus 2 or 2 minus 1? Tell me, choose anyone.
1 minus 2.
1 minus 2, right? Okay. So what is the x coordinate of the first particle? What is the initial position of x particle, the first particle?
0.
Second?
D.
D. Very simple. What is the 1 minus 2? How to write 1 minus 2? So you can see the 1 minus 2 means you have to write in because these are vectors. So the 1 is u1 cos theta 1 minus what is u2?
u2 cos theta 2.
No, it's minus u2 cos theta 2 because you're writing the x
Okay, sir.
component. Okay, you can see it's left because it is left, so it will become minus in itself, so it will become minus of u2 cos theta 2. So you have to be careful here. Into t plus half. Now this part is again easy. Why it is again easy? Because both will have acceleration due to gravity in the downward direction. We know that acceleration is same for all, for every projectile. So the second term is pretty easy for you to write because it is going to be g minus j, like minus g or minus. You can say minus g minus of minus g p square. Anyway, this is going to be 0. So your equation is so simple. It's simply d equals to u1 cos theta 1 plus u2 cos theta 2 into t. And in fact, you can get that t equals to a relation d upon. And you can see that both the x component is facing each other. That means they're coming closer. So the net velocity will add up. That's also logical, isn't it? So common sense says that, okay, if
Sir.
both are facing each other, yeah.
So
Tell me.
here we can write minus g now because it is in the y direction.
Yeah, so we wrote minus g. Minus g minus minus g. 0.
But we are finding for the x direction.
Oh, sorry. So this is not required. My bad. This is not at all required actually. Correct. Oh, I was thinking in the vector form. So this is not required because there is no accession here in X direction. Right? In X, we
Yes, sir.
don't have any accession. So anyway, this is the answer. Similarly, can you write the Y answer? How to express the same thing in Y direction? Please try it out, everyone. Try this for the Y.
Done.
Done, sir.
Very good. So tell me, like, what was your equation?
Z minus H1 minus H2 equals to U1 sin theta 1 minus U2 sin theta 2 T.
So H1 minus H2. Is it H1 minus H2?
So I got H2 minus H1.
Correct. Correct. Because when you're writing the answer equation, it is 0 minus this, right?
Yes, sir, minus of H1.
So then this is correct. Okay. Just a moment. Yeah. T turns out to be how much? H2 minus H1 upon U1 sin theta 1 minus U2. And now because we have two equations which is giving you the same answer, so you can equate it to relate the D H1 H2 U1 and U2. So you may be asked that what is the relation of D with H1 H2 and so on. So you can equate 1 equals to 2, and then you can get another relation. Yeah. So is it very difficult? I think no, it's not very difficult. So this was JEE advanced question of 10 marks in long time back. Very old question, definitely. You could have written, because it's 2 dimensions, so generally I prefer writing vector equation. You can write as R minus R not relative equals to U relative vector into T plus half A relative into T square. Now I'm not writing like you can say X, Y separately. I'm writing at one go. So at one go, how it will look like? So this will be 0 because under the projectile motion scenario, both will have same acceleration. So there is no question of a relative acceleration, isn't it? And when they will meet, this is 0. So your only question to write is minus R not relative is U relative into T. That's it. And this I can write. How? So the first particle is having 0 I cap plus H1 J cap minus second particle will have d I cap plus H2 j cap, and I'm pretty much easy, so right, and this will be u1 cos theta 1 I cap plus u1 sin theta 1 j cap minus u2 sin u2 cos theta 2 I cap and plus u2 sin theta 2 j cap into t. I'm done. What we do next is we compare the I with I, j with j, and we get the same answer. Understood? Is this clear?
Yes, sir.
But we do have a third method also, which is really powerful. Okay. So what is this third method? So I will introduce you something called G frame. So G frame basically means if every particle is having same, accession same equals to G. So I will bring a third observer, which also starts, falling under gravity at the time you throw the projectile. So that observer will have accession G with no initial velocity. And because other particles 1 and 2 also having the accession G. So for that guy, he will not see any accession, isn't it? Because all are free falling downward. Are you getting my point? What I'm saying? If everyone is having same accession, then will they able to see the accession?
No, sir.
So for that guy, the particle will be accelerated or non-accelerated. What do you think?
Non-accelerated.
And if it is non-accelerated, then what will be the path of each particle? If G vanishes, some imaginary thing that G is not present, then how they'll perform the path? The trajectory in that frame will be what? A parabolic trajectory or a straight line trajectory?
Straight line.
Exactly. Siddhant, you got the idea? What I'm saying?
Yes, sir, partially.
So once again, it should be fully. 1, 2, particles 1 and 2, you have thrown like this, U1, U2. What is their accession? G.
Yes, sir.
So I have a third observer. There is a frame of reference, which is also free falling. Okay. And it starts free falling at the exact same instant when you throw these two projectiles. So the person in this frame will never see the acceleration part, isn't it?
Yes.
Because they all have same acceleration. So will you see the free fall? Answer is no.
No, sir.
So what does it mean? If you don't see the free fall, then what will be the path of 1 and 2 as seen by the person in the G frame?
The straight line.
A straight line. See, the idea is why we are learning relative motion, because time is invariant and time remains same in every frame of reference. So we choose a frame which is convenient for us. So that is the benefit. The time is the calculation of time can be done or performed in any frame. Okay, we will not perform the calculation of position and all, but the calculation of time can be performed in any frame, and no matter which frame you choose, you're bound to get the same answer. Understood?
Yes, sir.
So we can reduce the effort if we think this as a straight line path. If you choose a G frame, what will happen? It will appear that both are moving in their respective trajectory, respective initial velocity direction, performing the straight line motion. Okay. So how the question will look like? So let me draw this diagram once again. So we have two towers. So if you have thrown the first particle like this, it will keep on going like this forever. And if you have thrown this particle like this, it will keep on going like this. So if they are meeting, then the only point they can meet is this point, isn't it? Do you see the point of intersection of these two paths?
Yes, sir.
So in his frame, if they are meeting, it means they must be meeting at the point of intersection, isn't it? This is U1, theta 1. Now tell me, let's say they meet at time t equals to t. So how much first particle will travel in its straight path?
U1,
U1t. Second,
U2T.
U2T.
you can draw a perpendicular just for the sake of geometrical construction. A basic trigonometry will give you the answer. So can we write d equals to u1t cos theta 1 plus u2t cos theta 2?
Yes, sir.
Because these are length, na? This is length, this is length. So component of this here will be u1t cos theta 1. This will be. And if you add these two, you get d, isn't it?
Yes, sir.
Is this clear to all of you?
Yes, sir.
Yes, sir.
So the things are very simple. We got the answer d1 equals to u1t cos theta 1 plus u2t cos theta 2. Let me write it clearly.
So can we use this method like in most
Yeah,
of the
yeah.
questions?
You can use this method only when in the frame there is no acceleration, and you can do it for any acceleration, not only G frame. If you know that if the two particles are having the same acceleration, then you choose a frame with the same acceleration, then you are not supposed to think about acceleration, you are supposed to think about only velocity, and then solve it. I'll show you some more questions. So we can add d equals to u1t cos theta 1, u2t cos theta 2, and we are done. So t equals to similarly, how to relate the H1 H2? So you can clearly see that the vertical height of the meeting point from the base we can express in two ways: H1 plus U1t cos sin theta 1, H1 plus U1t sin theta 1. This must be equals to, from left side I can write like this, from right side what we can write? H2 plus
U2T sin theta.
and let's say U1 is more than U2, definitely it should be, then only it can meet. So U1 sin theta 1 minus U2 sin theta 2 into T is H2 minus H1, and we are done. In fact, I will suggest that every question of projectile motion you can solve in G frame mentally, ignoring the what should be ignored? The parabolic path. You can just solve by assuming straight path and ignoring the acceleration part. Because I have freedom to choose any frame. So I can always go to a frame which is convenient to me. And because the time calculation is like I mean something which is independent of the frame of reference, so I will get the same answer as I would have got in any other frame, in the ground frame as well. But it doesn't mean that if they will ask you at what height they will meet, you cannot say the same. If they are saying at what height they will meet, you cannot say the same actually. Understood? Yeah, Ursha, why you're joining so late? Am I audible to you, Ursha?
Yes, sir.
So why you're so late?
Sir, exam was there in college,
Okay.
so I came just now.
All right. Is this clear? Harry, you understood?
Yes.
Rugved, you understood?
Yes, sir.
So there are many ways, like every question can be attempted in many ways. So let me give you some very challenging program which you can solve just like this mentally. But I'll say, okay, I'll encourage you to solve by all the three methods one by one so that you can understand and have the good grasp of the methods. So let's say we have a tower of height h, and two projectiles are thrown simultaneously. One is thrown like this, other is thrown some angle, and even the angle is not given, which is in fact not required. V1, V2. And they meet. The question is they meet. So I mean the first particle will traverse a path like this, and second will traverse a path like this, and they are meeting here actually. And the question is, after what time they'll meet? So after what time they'll collide or meet? So both will have same acceleration or different acceleration? Tell me.
Same angle.
Same.
Same as.
So there are many ways you can solve, like, you can choose the proper coordinate system. Say X and Y, say origin. Assign the coordinate of each particle. This is anyway 0, 0. This is 0, H. And when they will meet, they will have some coordinate X and Y. Correct? You can solve in ground frame, a relative frame, this frame, that frame, whatever you want to solve. What is not given here is at what angle V2 is thrown. So when it is not given, what we'll do, you will assume some angle before you solve. And that will be variable, which you can get from the equation. So attempt this question by at least 2-3 methods. Everyone.
So this angle of projection of second particle given.
No, it's not given. You have to assume it. It's like some sort of variable, because this will happen only for one particular angle. So angle you can also determine using the condition. Think organically, you will get the answer. I mean, in fact, even if you don't know the relative motion, you can still solve this question. So the idea of a relative motion is not mandatory to solve question. In the chapter of a relative motion, we make it easier. That's it.
Sir, I'm not getting how to solve this.
So you can see that both the particles will have same x coordinate at the time of meeting. Yes or no?
Yes.
You know the x coordinate of each particle in the beginning.
Yes, sir.
So can you find the x coordinate of the same particle at after time t?
So how to find?
Using the kinematical equation. You know the initial velocity, you know the acceleration in the x direction. You know the velocity in the x direction. So you can write the x coordinate. S equals to ut plus half t square. Or x minus x naught equals to uxt plus half x. So you can add the x coordinate of each particle after time t and equate it because they have same value. So for the first particle it is v1t, that's it. And for second particle it is how much? Okay, so we need to assume some angle, right? Theta. Let's say theta. So what you can write? For the second particle, what is the x component of velocity? The x component of velocity of the second particle is how much?
So
v2. This is theta, no? So this is v2 cos theta. This is v2 sin theta.
sin theta.
So you can add v2 sin theta into t. And these two must be equal, isn't it? This must be same as this.
Yes.
So if you equate, what will get? From 1 and 2, if you equate, we will get v1t equals to v2 sin theta into t. T gets cancelled. So you get the unknown sin theta equals to how much? v1 minus v2, v1 upon v2. So of course v2 is much more than v1, then only it is possible to collide.
So where that half at square went?
Okay, so because there is no access in the x direction, in any projectile motion, gravity will act like this.
Yes.
So what is the acceleration component in the x direction?
0.
So the term becomes 0, yes.
Okay.
But in y direction it will be right, it will be present. So what is the y coordinate of the first particle?
H.
So y minus h equals to what is uy? What is the y component of the initial velocity of the first particle?
Sorry.
No, velocity. The component of velocity of the first particle.
V1.
But v1 is in the x direction, no? What is the component? You know component, how to resolve vectors? Do you know?
Yes, sir, but can you elaborate on this term component?
Component means if we have a vector like this is theta, so the component is the effect that it will produce in the x direction. So x component means v cos theta, y component means v sin theta.
Okay.
So what is the component of v1 in the y direction?
V cos theta.
v1 cos. What is the
V1
angle of
cos
angle between v1 and y axis?
90.
So component means take the cos of the angle between the vector and the direction. That's it.
Okay.
So v1 cos 90. What is v1 cos 90? Cos 90 is how much?
0.
0. So v1 cos 90 will be
0.
that's it. So 0 plus what is the ay? The acceleration in the y direction?
Minus G.
That's it. Similarly, can you do it for the second particle? This is the ground frame of solving question. So for particle 2, can I just y minus 0, this is 0 only, equals to V2 cos theta t minus half g2 square. That's simple. So you can just equate it, you will get the answer. So here we haven't used any concept of relative motion. We're just starting the ground frame answer, x value, y value, and we're equating it. So if we equate, what we'll get? We'll get y minus y equals to h minus half gt square, and y equals to also v2 cos theta t minus half gt square. And if you equate it, you get h equals to v2 cos theta into t. So t equals to h by v2 cos theta. But we know sin theta, we don't know cos theta. How to write cos into sin?
1 month.
Under root of 1 minus what?
Sin theta. Sin square theta.
And because you know the sin theta, you can substitute the value. Which will give you the answer h upon 100. Now this is really cumbersome. This way of writing is not required because you're not supposed to write so many equations and then simplify this. You can get the answer in one line. So the other method is, okay, I hope you guys have done with the vector, the relative motion. Siddhant, Harry,
Yes, sir.
tell me.
Yes, sir.
Rugved? You got the answer, Rugved? Yes or no?
No, sir, I'm still doing.
Why? What you are doing? Like what exactly you do? I mean, if you're still doing, then what you are exactly doing? What you're doing? Tell me.
X coordinate will be X, then initial will be H minus 0.
Which equation you are using to solve the question? First of all, like what is your approach?
X relative minus X not relative equals U.
Equals so x relative minus x not relative equals to u relative. I'm not writing x, so this is u relative into t, right? Because there is no access in the x direction.
Huh.
And this is 0 anyway at the time of meeting. So what we are left with only this equals to, right?
Yes.
Then you have to choose some coordinate system. You have to choose x. This is origin. This is y axis.
Yes.
And then you're supposed to substitute the value.
Hmm.
So x naught is, this is 0 and 0. Everything is 0 only. And the u relative is again easy. So what is ux relative? V1 minus. So you have to choose some angle theta. And write V2. What? That's it. So this will give you the answer, same answer. V1 equals to V2 sin theta. See, the common logic is, common sense is that to meet at a point, they must travel equal distance in the x direction. And because they have the similar x coordinate in the beginning, so they must travel the same x value, which means they must have the same x component, isn't it? That common sense. The x component of velocity must be equal, then only they can meet. Yes or no? If you start with the same x coordinate, then to travel equal x displacement, you must have same equal x component of velocity. Yes or no?
Yes.
So there are many ways, no? Yeah, why we need to write even these things? Okay. What else? What about y?
Zero minus H.
This is again 0. Why? Because they have same axis in the y direction. So y not relative is what? H minus 0, let's say 1 minus 2. And this is 0 minus, that's it. So we are done. If you substitute properly, you'll get the answer. T equals to HY. And from here, you can get the sin theta in terms of V1, V2. You can substitute here. You'll get the answer. Is this clear?
Yes, sir.
So which is that first equation?
Pardon?
That first equation.
Mhm.
Yes, which
Okay,
I
what you
didn't.
can do is you have to watch from the very beginning. So you have to watch from the last lecture. I'll share the lecture. Okay. So you can start watching those lectures and you will understand everything very clearly. Okay. So a lot of lecture I'll share with you, which you can start watching as soon as possible. Okay.
Okay, sir.
Don't worry. Because you are in the middle of something, so it will be difficult for you. Try to understand what I'm saying. Okay. I'll try to explain also in between. So now this is the
Okay.
method 2. What is the method 3? We could have done this in mentally or one line. So G frame. Do you remember the G frame? Anyone? What is G frame? So we all know that both will have same acceleration equals to G. So if I have a third observer, a third person with the same acceleration as G, in that frame, what will not be present for these two particles?
Acceleration.
So there is no acceleration, isn't it? And if there is no acceleration, what will happen? They will move in a straight line. So what is the condition of meeting? So in time t, how much first particle will travel?
One.
Second, separation is, this is a right angle triangle, we know Pythagoras. So V2t whole square is how much? H square plus. If you solve, you get the answer here. That's it. Done. How much time it takes to solve? Less than 30 seconds. In fact, you can do this mentally. So the power of G frame is from the parabolic path, we go back to which path? A straight line path, and then the diagrams are very easy. Is this clear to everyone? Tell me.
Yes.
Clear?
Yes, sir.
Siddhant, tell me. Rugved,
Yes, sir.
are you really getting it? Or you're just saying yes, sir? Tell me.
No, sir, I got it.
So this is the same idea, that same idea which we used in the previous question. Let me give you something more detail, some more deep insight about the collision problems or G-frame problems. So I'll talk about condition for collision. So let's dive deeper into the collision problem. Whenever we have two particles in which there is no relative acceleration, so they may have acceleration, but there is no relative acceleration. So we are not assuming that they have any acceleration. You throw the first particle this way, V1. Let's you throw the second particle this way, V2. At some angle θ1, some angle θ2. And this is the separation. So separation you can call as you wish, you can call anything. It's called D. Okay. Now, to deal with any projectile motion, the best way to think is assume one of them at rest, one of them as observer. So out of the two particles, imagine you become the observer. So I'll make it more general, like So let's say this is the first particle position from the some ground frame. This is a particle position from the ground frame. So this we can attach. This arrow will represent what? Position vector of 2 with respect to 1, right? And this arrow will represent what? Position vector of 1 with respect to 2. Yes or no? Tell me if you are getting it.
Yes, sir.
So since we have the two particles 1 and 2, and because I can represent their position vector from the ground R1, R2. So ground person will tell you 1 is there, 2 is there. But if you ask 1, where is 2? Then he will point his finger towards the 2 in the right direction. So that's why we write R21. R21 means what? Position vector of 2 as set by 1. Similarly, R12 means position vector of 1 as said by whom? 2 or seen by 2, observed by 2. So the relative notation is clear to all of you?
Yes, sir.
Okay. Now the next step is make one of them as observer. Make one of them as observer. The moment you make one of them as observer, that means that guy, that particle is not moving at all, because you cannot move with respect to yourself. So with the moment you become the observer, your velocity becomes meaningless, isn't it? But the moment you become observer, will you see V2 or will you see something different from V2? If one is the observer watching 2, will he be able to see V2 or something modified of V2? Tell me. Okay, I think you're not getting it. None of you are getting this. V1, V2 are the ground frame velocity. But if V1 becomes the observer, will he be able to see V2?
No.
Can you see the actual motion? Let's say you are in a car, your friend is also in a car. Okay, in a car moving parallel to your car. So let's say the two cars are parallel to each other. And both are moving with the same speed. What you will see about each other? So in the frame of the first car, second car is at rest, vice versa.
Yes, sir.
But the reality is in the ground frame, they are both are moving, isn't it?
Yes, sir.
Yes, sir.
So in the relative frame, do we see reality or do we see the relative reality? It means what you observe is not real, not accurate as per the ground frame. Yes or no?
Yes, sir.
So when V1 is watching V2, can he watch V2 first of all? Will he be able to see exact V2? Yes or no? Is my question clear what I'm saying? My question is, if V1 becomes observer and if V1 starts watching V2, I know V1, V2 are the velocity in the ground frame. But if I ask V1, what is the velocity of V2? Will he say V1 or V2 or like what he will say?
V2
Different
minus.
from V2 minus V1 vector, right? So velocity of 2 with respect to 1 cannot be V2, right? What is this value? V2 minus V1. Isn't it?
Yes, sir.
And in vector, what is the meaning of negative vector? A vector with a reverse direction. So minus V1 will have direction opposite of V1 vector. Is this clear? Is this clear? Tell me. Yes or no?
Yes, sir.
So the whole idea is if I choose one as observer, then the velocity of 2 will be having two component. One, the actual what you had. So V2 you had actually. And a reverse. See, if you remember V1 was like this, what is the reverse of V1? Like this. Correct? If V1 is like this, just a minute. This was actual V1. What is minus V1? a reversed vector, right? And V2 plus minus 1 means this value. So you have to add V2 and minus V1. It's like this. So this is theta 2, this is theta 1. If you remember, we have just reversed and attached the first vector, the V2 vector. And because there are two vectors, what will be the resultant? Somewhere in between the vectors V1 and V2. So if you remember the triangle of vector addition, then only you can understand, else it's very difficult. Are you able to understand this? What is happening here?
Yes, sir.
V2 is vector, which you have. Minus V1 is what I have imparted. So this is V2 vector. This is minus V1 vector. And by joining tail to tail, I'm going to get the resultant. Now, what are the possibilities of resultant? It could be like this. It could be like this. Or it could be like this. Once again, the resultant of the two vector could be like this. Yes or no?
Yes, sir.
Could be like this also. Or like this also. All three are possible, right? On the side above this, or exactly this and this. So tell me, guys, what should be the condition for hitting the one? Like when it will hit the first particle. If it will go this way, will it hit?
No.
It will just pass like this. If you go this way, it will hit. No.
No.
So condition for hitting is what? What should be the condition for hitting?
The resultant should be along V1, along 1.
The resultant vector should be along the initial line of joining 1 and 2. Okay. So whatever is the line of joining of two particles, the V12 must be aligned with that line, then only it is going to hit. Otherwise, there is no question of hitting, isn't it? Do you realize what I'm saying?
Yes, sir.
So condition for hitting. Siddhant, are you getting it?
Yes, sir.
Rugved.
Yes, sir.
So what is the condition for hitting or collision? It could be anything. You can say collision, hitting, meeting, whatever. So condition for meeting is what? If you remember, this was the position vector of 2 with respect to 1. And this is what? Position vector of 1 with respect to 2. And this is what? Velocity of 2. So what is the condition for collision? So condition for collision is what? Which two vectors must be parallel to each other? Can you see the vectors which are parallel? Look at these two vectors. Are they parallel? Are they parallel? Yes or no? Are they parallel? Guys, tell me.
Yes, sir.
So what is the condition? How to write in vector form? How to express the condition in vector form? Tell me. How to write the condition in vector form? Any idea?
V2 sine theta 2 should be equal to minus V1 sine theta.
No, these are, see, V1, V2 are now values. The moment you express it, V1, V2 represents values. Minus V1 vector is the name of the vector. It's not a value. Value is V1 only, right?
Yes, sir.
So condition, I'm saying now the vector condition. You are saying the component wise, which is good. But what I'm asking is what is the vector condition? So for collision, V21 vector must be parallel to R12 vector. Do you realize this? Are they parallel? Yes or no?
Yes, sir.
Not just parallel, you can say collinear. So they are like collinear. They are like collinear, right? Now, so I'm going back to vector chapter, which you certainly don't remember. So if two vectors are parallel, then which condition will hold true between them? Siddhant will tell. I hope you have studied the vector chapter. Rugved, can you tell?
Sir, can you repeat the question?
If two vectors are parallel, then which condition will hold true, or which equality will hold true between them?
Dot cross product is 0.
Yeah, that's also correct. What else?
So can we say one is a multiple of the other vector?
See, if the first vector is position vector, other is velocity vector, then one cannot be multiple of other, because a mango cannot be, multiple of banana, isn't it?
Okay, sir.
So you are comparing the two vectors, apple with banana. So the answer is this. If two vectors are parallel, then if two vectors are parallel, then their unit vectors must be equal. So we cannot compare the two separate vectors, but unit vectors are those vectors which are having no dimension. They are just a number and a direction. So the condition is V21 divided by V21 mod must be equals to R12 divided by its modulus. Because if you express in number and unit and direction, then the unit from the numerator and the denominator will cancel out. So in the numerator, we have number, unit, direction. In the denominator, we have number and unit. So this unit gets cancelled. Number gets cancelled. So what you get is only direction. And they have same direction. So they are equal. And again, if you're not getting this, go back to the chapter of vector and do read about it in detail. So this is the condition. And you can elaborate as V2 minus V1 equals to. So the V2 minus V1 upon V2 minus V1, this is same as R1 minus 2. See, there is the difference. It's 1 minus 2. It is clear? And the other thing which you said is also correct. What you said? The cross product must be. So V21 cross R12 must be null vector. It is clear?
Yes.
Clear, guys. Tell me. So of course you can solve this way also. This is correct. Nothing wrong about it. So when two vectors are parallel, then these are two conditions. The first condition which I derived is a question from Erota directly. This is a question. Number, let me tell you. So question number 1.5. Do you have the this Erota book right now? Let me show you. Just a minute. So can you read the question 1.5 from Erota? So this was the question that if V1, V2, R1, R2 are the values, then find the condition for collision, right? Or meeting out here. Can I read the question now? Hello, hello, hello. Am I audible, guys?
Yes, sir.
Yes, sir.
You read the question?
Yes, sir.
Okay. So now this is the condition for collision. This is very important. And this is when we try to solve the question, we can invoke this idea. Okay. So now what happens if it is not parallel? What will happen? Tell me. What will happen if it is not parallel? So if one is here, two is here, this is R21, this is R12, and let's say this is this is your V21. So the velocity of 2 with respect to 1 is this way. In that case, it will never hit, but it will go like this. So now you will be asked to answer that what is the minimum separation possible between the first particle and the second particle. The second particle will continue to move like this, right? So path of second particle as seen by the first particle is the red line, isn't it? So path of second particle as seen by first particle is a straight line. Is a not straight line, I want to say is a red line. Now tell me at what instant the separation between the two will be minimum? So after some time the two will be here. Now this is the separation. Then it is here. This is the separation. So when the separation will be minimum? Can you guess?
Sir, when both of them will be perpendicular.
Not both of them. When you drop a perpendicular from the one to the red line, and yeah, so when the two is here, then they will have minimum separation. So you will be asked to sometime find the minimum separation. In case they fail to hit At some instant, they will be very close to each other. What is that minimum separation that we are supposed to find? Okay. So I can call this as theta. What is the minimum separation? Can you guess? So this we can write as R12 or R21 mod, the distance. And if this is theta, how to find D minimum in terms of R12? Tell me. D minimum in terms of R12, the mod value. Just use the triangle, no? In this right angle triangle, what is the D minimum? Tell me, guys. What happened to you guys? You know sine cos tan. So what is the relationship between D minimum theta and this? Okay, you can't see the triangle like this, right? You are only okay with this kind of triangle, isn't it?
Tan theta equals D minimum by R12.
Theta equals to D.
Is it tan theta?
So sine theta.
Sine theta. So sine theta is how much?
D minimum by R12.
D minimum by R1 or R21, whatever you can say, R12. So I will take R12 because of some reason. So I'll take R1. So we got a D minimum equals to R12 into sine theta. But is the theta given to you? Do you know theta? Is theta given to you? The answer is no. What is given to you? Only the position vector and the velocity vector, R1, R2, V1, V2. So theta is not given to you. So how to get theta in the vector form? So which product of vector gives us sine theta? Tell me. Dot or cross? Sine theta appears in dot product or cross product? Sine theta appears in dot product or cross product?
Cross product.
Cross product. So if I, you can see, if you see this triangle, you can also see something. And what you can see, that theta is between which two vector? Theta is the angle between this vector and this vector. Do you realize this? Theta is the angle between R12 and V21. Yes or no?
Yes, sir.
And if that is the case, I can take the cross of the two. So I can write R12 cross V21. And if I take a modulus, it will be R12 mod of V21 into sine theta. That's it. So what I'll do is, because I know the definition, I can write as R12. What is missing is V21. I'll put it here. And I'll divide it because it's not there actually. And the numerator we can rewrite as now this is the complete vector representation of minimum separation. So given the coordinate, we can find the minimum separation without any ambiguity. Is this clear? Hello, hello, hello. 1, 2, 3. Rugved, is this clear? Rugved, Harry.
Yes, sir.
Yes, sir.
So do you realize what is happening here? Okay. So these things are not very easy unless you are not good with vectors. So if you have done a lot of vectors, then you will find yourself in a comfortable position. Else, yeah, I can understand these things are difficult one. The other question they will ask you, okay, so it's the D minimum. So the next question is, okay, you can let me put a heading also. And from here, if I want to know the collision relation, so collision means what? The D minimum will be how much? If they are actually colliding, then the D minimum must be
0.
0. So it is 0, correct. So the idea is simple. If they are going to collide, it means the separation, the minimum separation must be 0 because they will meet at the same point. But if they fail to collide, then there is a formula. We can always use the formula. If it R12 cross V21 is 0, it is 0. If it is non-zero, it means non-zero. Okay. So this vector method is a powerful method to solve many questions with ease, but that requires some sort of practice also. The next question is, what is the minimum separation? Sorry, after what time they will be at the minimum separation? So time after which the time after which they will be at minimum separation. So this is the next calculation. Okay. So how to relate R12 with time in the same triangle? Which equation will be beneficial for us? So you can see time is here because in time t you will travel how much? V21 into t, isn't it? Tell me. Velocity into time is displacement. So V21 into t is the displacement. So what is the relationship between theta, V21t and R12? Tell me, guys.
Cos theta.
Cos theta. Very good. So you can add down. So cos theta goes to how much?
V21t by R12.
So V21 modulus t into mod of R12, right?
Yes.
So this will give you t equals to how much? Now we can rewrite this as V21 and we know that V21 into R12 into cos theta we can write as A dot B, right? This is dot product. So we can write as you can write the way you want R12 dot V21 upon take a modulus on here because this becomes V2 square actually. Why modulus? Because time cannot be negative, but dot product can be negative. So we make sure that we have a positive answer. So these two questions are asked in a difficult situation. You are supposed to answer like this. Okay. So I'll show you the previous question which we solved. This question. Yeah, this question. In a new way again. A somewhat a fresh way of looking at the same problem. So same old problem. V1, V2. Okay. And these are just two particles, so it's not very difficult. Okay. And okay, the angle between the V2 and the H is not given, so I'll start with theta. First of all, you need to realize that they will have same acceleration, so there is no relative acceleration, isn't it? There is no relative acceleration. Okay. So this is first particle, this is second particle. The next question is, you have to make one of them as observer. So now tell me which one you want to make observer. Tell me first of all. One or two. Choose one of them as observer.
One.
One. If one is observer, what will be the velocity of one with respect to one? Tell me
Zero.
guys, velocity of one is 0. So it means it will have nothing. So it is at rest.
Yes.
It is at rest, yes or no?
Yes, sir.
Now, if you talk about two, now two is not alone. Now two is being observed by one. So we have to write everything in the frame of one. So two will have its own velocity. Two will have its own velocity. And the velocity it will gain due to the one. So velocity of two with respect to one means what? V2 minus V1. So the velocity of one is towards the right. When it will go to two, the direction will be reversed. So it will get like this. Isn't it? Do you realize this? Yes or no?
Yes, sir.
So two will have two velocity, its own velocity and by virtue of the observer. So observer will always give its velocity in the reverse direction. That's logical thing. And what I said that they will collide, isn't it? If they will collide, it means the resultant of V2 and V1 must be in which direction? What should be the direction of resultant of V2 and V1? Can you guess?
Along line joining one and
Along the line joining the particles. That's correct. And that means the component which is perpendicular must be cancelling out each other. So to move along the line joining the particle 1 and 2, which component must cancel out each other?
V1 and V2 sine theta.
Exactly, because unless they are not cancelling, it will never go along the line joining the 2 and 1. So the rule is we always resolve velocity along the line joining the particle and perpendicular to it. And if they are colliding, it means the perpendicular component must be cancelling out each other. So for collision, the V1 must be equal to how much? V2 sin theta. Is this clear, guys? Tell me yes or no.
yes, sir.
So see, we got the same answer, no? First question. And then because 1 and 2 sin theta, this is cancelling. So the net velocity left is how much? The net is always the one which is along the line joining 1 and 2. And that is how much? V2 cos theta. So time taken by this to reach 1 will be how much? After what time to reach here?
H by V2 cos.
H by V2 cos theta. See, we got all answer. We are done. And you can substitute the value, you know, this will be. So there are many ways of thinking. Do you realize this? How many ways you can think are same problem? You have to think that, you know, which method will be most convenient to me. Okay. So are these all methods clear to you guys? Tell me.
Yes, sir.
So which was the time formula?
This one.
No, next. This one, which is this formula, means general form.
No, there is no general form. There is no formula. We are solving one particular question, and this is the answer for that particular question. There is no formula.
Okay.
Formula is this one. This is the formula for time. What is the formula? R12 dot V21 upon V21 whole square. Can you see
Okay.
this?
Yes, sir.
Let me show you how to use this. So you have to derive the formula in kinematics or in physics. You're not supposed to use any formula. So kinematical equations are only those equations which are the fundamental, then you have to use it. Even those equations are not fundamental, the definitions are fundamental. Definition of velocity, acceleration, and from there we derive all those relations. Okay, so it's a really long journey. All right, so we'll see some interesting question. So let's say we have two crossroads. The two roads are mutually perpendicular. At some instant, the first particle is moving with velocity v1. The second particle is moving with velocity v2. Let's say call this as origin, this as x-axis. So at the instant when you see this situation, the distance of first particle from origin is L1 and the distance of second particle from the origin is L2. Find time after which they will have minimum separation. That's the question. And also find the minimum separation. So there are two questions. Find minimum separation. And also the time at which it will be minimum. And also time so the simple way is take one as observer, other as rest, then proceed. So anyone interested in trying this question? Harry, you want to try?
Yes, sir.
Rugved? No.
Yes, sir.
Done. So let me show you how to proceed with question like this. Okay. So for the first time, these questions will be difficult. Don't worry about it. Every question of relative motion will take some time to realize and digest. So it is relatively new for you to, do the vector addition. But if you have read the vector chapter really good and practiced a lot, it won't be a difficult task. So once again, so let me take it here. So we have the first particle here, second here. Choose one of them as, observer. So which one is observer?
1.
One. So if one is your observer, one will have nothing. Okay. So now two will have two velocity, two will have v2 and v1 like this, isn't it?
Yes, sir.
So you can do it better. So I will make it intentionally something like this, v2 and v1. So the resultant of the two will be something like this, isn't it?
Yes, sir.
So the minimum separation will be when it is you draw a perpendicular from here to here, correct? This is the minimum separation. Okay. Because one is at rest, one will do nothing. So only two is moving. So as one will feel that two is going in this path, so this is your v21, isn't it? This is your v21. So it will go like this. So the minimum separation is this one. So if I call this as theta, we know this is L2. So if this is L2, this is how much? Because this is also theta. So how much is this value? Tell me, this is how much? In terms of theta and L2, that's it. In terms of theta and L2, how to write that value, the missing value?
L2 tan theta.
Very good. So we cannot say this is something x or whatever d. So tan theta is how much? D by L2. Okay. Tan theta is d by L2. So d is L2 tan theta, which is correct. But also, if you look at the diagram, tan theta is the resultant of the vector velocity vector v1 and v2. So numerically, tan theta is also equals to v1 upon v2. Do you realize this?
Yes, sir.
So the d turns out to be how much? L2 into v1 by v2. That's a d2 and d value. And once you get this value, this will be L1 minus d, correct? So can we write d minimum equals to L1 minus d cos theta? Can we write like this? Tell me.
Yes, sir.
So we are done. So L1 minus d, which is L2 v1 by v2. And because we know tan theta is v1 by v2, so we can also find cos theta. So tan theta is v1 by v2, and we know the cos will be v2 by v1 square plus v2 square under root. If you're not getting it, why it is so? You can draw a triangle always. So draw a triangle like this. Take this as theta. Tan theta is v1 by v2. So the hypotenuse will be how much? Under root of v1 square plus v2 square. And therefore we can write cos theta equals to base upon hypotenuse. So this is the answer, V2 upon. And if you rearrange, it will give you the answer like L1 V2 minus L2 V1. We will take modulus because we don't know whether it's positive or negative. So because this line could be on this line, this side also. So that's why the answer comes this way. And upon will be. Is this clear, guys? Tell me yes or no.
Yes, sir.
Can you solve this question by using the formula R12 cross V21 upon V21? If you remember this formula. Yeah. R12 cross V21 upon V21, because why I'm saying this, because this is easy here, because you can write the X and Y coordinate easily for each particle and just substitute the value. So try this relation and tell me whether you're getting the same answer or not. So use I, J cap, I cap, J cap, and so on, and express the answer. Take the modulus, you will get the answer.
Yes, I got the same answer.
Sir, what will be V21?
Yes, tell me.
What will be V21?
V21 means V2 minus V1, right? V21 is V2 minus V1. And you can see V2 can write as V2 J cap and V1 is how much? V1 I cap. This is V2. So if you take a mod of it, what will you get? Under root of? Understood.
Yes.
And similarly, connect the R12. So what is
R12.
R12? R12 is 1 minus 2. And R1, you can see it's a minus L1 I cap. And R2 is minus L2 J cap, isn't it?
Yes.
Yeah. So what are you getting here? R12 equals to L2 J cap minus L1 I cap. And then what you can do next is put into the cross product this formula. Okay. You will get the answer. Isn't it? Is this clear?
Yes.
Yes.
Okay, so I'll stop the lecture here today because see, I mean, many are facing the internet issue today and many are absent. So we'll continue with more of examples from the relative motion in the next lecture. All right. But now you can start solving from the sheet which I have shared. Is it okay? You all have received the sheet? Yes or no? Have I shared in the last lecture?
Which one?
Just let me check if I have shared or not. Okay, I'll share. I'll share it right away. Don't worry. Just a minute. Yeah. So Aisha, I'll share with Amit sir. You can get it from there because I don't have your number.
Okay, sir.
Yeah.
So that
Yeah.
vector chapter you told to read, that from which book?
No book. You have to watch lectures. I'll share with you.
Okay.
Okay. Okay. All right, guys. Bye. Take care. Thank you.
Thank you.